I just got a message from the headquarters, so please turn in the delegate evaluation form to the CTBUH booth. So if you have filled in the delegate form, then please turn it to the desk. And I'm going to introduce the next speaker, and Captain Michael Stein FDNY, and he holds multiple patents on safety equipment for firefighter, and he has a licensed electrician and a licensed plumber. And he's currently a communication consultant and instructor for fire command consultant. And we are going to talk about the in-building fire department auxiliary radio communication system. Please welcome Captain Mike.
Thank you. Good afternoon. I just want to thank the CTBUH for allowing me to speak today. It's always very impressive to see a distinguished group such as yourself so proactive in the needs of the fire service. Became very apparent after 9/11 that we needed the support of the engineers and the architects and the design of these buildings to support our needs during the operations. I'm going to talk a little bit about auxiliary radio communication systems today, something that's very important to the fire service in these high-rise buildings. Back in 1977, when I first started in the fire service, it was a movie that I was very impressed with. It was called The Towering Inferno. I think most of us know of the movie. And in the end, the chief, played by Steve McQueen, exits the building at the end of the fire and sees the architect, played by Paul Newman, and he says to him, you architects are going to continue building these buildings the way you do, as high as you do, and we're going to continue putting the fires out in them and rescuing the people, and someday we're going to get together and decide what has to be done for the fire service to make them safer for everybody concerned. And I'm pleased to see that this is occurring, and more so since 9/11 than ever before. It's very impressive. Imagine being a chief in the fire department and arriving on location and seeing something like this, knowing that you're going to be sending 100 to 150 50 personnel up into a building like this and jeopardizing their safety. One of the most important things that the chief wants on that location is communications with his people to properly deploy his resources. And I'm going to play a little audio clip, and this is actual audio from fires that we've had in New York City. And you can hear some of the information that is given over the radios. And without the infrastructure properly placed in these buildings and the proper communications in the buildings, this information will go unheard in the lobby where the chief needs to hear it, as well as the firefighters on the upper levels who have to hear possible evacuation orders. And that was all audio from actual fires that we've had. And you can only imagine that if the chief was down in the lobby and didn't hear all that information, how it could jeopardize the outcome of the operation. A little bit about my background. I was the head of the research and development unit for the New York City Fire Department for 5 years prior to my retirement. While I was there, our job was to make sure the firefighters had all the proper safety equipment they needed, and as well as anything new coming into the fire industry, we would test it, pilot it, and after 9/11, one of the things they tasked us with was trying to solve some of the communication problems that were evident on 9/11. So we put together a team of guys and did some extensive testing of high-rise communications in excess of probably 150 high-rise buildings, where we determined that we did have a severe lack of communication in many of those buildings. So something had to be done. So they asked us to come up with a solution to the problem, and the team got together and developed what they now call the command post radio. And this is a high capacity radio, very powerful to penetrate the concrete and steel, and every chief carries one now in the New York City Fire Department, and it allows them to establish a command link between the floor below the fire and the lobby. And this gives him the ability to talk to the lobby and call for more resources, and then he uses his walkie-talkie and talks from the floor below the fire to the firefighters that are operating on the fire floor. So this was a great improvement after 9/11, but it wasn't the solution to our complete communication problems. We then developed an auxiliary radio communication system that we installed in the Chrysler building with the support of Tishman Speyer and their people. We did extensive testing on it. We did proof of concept for the fire service to prove that this was a viable answer to the firefighters being able to communicate with the lobby. There were many studies done after 9/11. McKinsey Group was one that the New York City had hired to determine what the shortcomings were after 9/11. You had the NIST investigation, National Institute of Standard and Technology. They did an investigation. 9/11 Commission report, the Association of Public Safety Communication Officials, as well as our own FDNY ARCS committee, which evaluated the communication issues. And every one of them came up with the same thing, that there had to be some sort of infrastructure installed in these buildings to address the firefighters' needs when it came to communications. So how do you do that? Well, the 2003 International Building Code put in a section 907.2.12.3 Fire Department Communication Systems. And the New York City Department of Building Construction Code of 2008 adopted that, okay? And that code went into effect July of 2009 for New York City, for new buildings, okay? So what was a two-way fire department communication system, according to the code? It was a communication device that must operate between Fire Command Center in the lobby and all the elevators, the elevator lobbies, the emergency power rooms, fire pump rooms, areas of refuge, and inside each enclosed stairway at each floor level. So what this meant was, if you had a 50-story building with 4 stairwells in it, you had to put in 200 telephones, hardwired telephones, in each stairwell at each level. And the reason that this, you also had to do it in the elevators, elevator lobbies, emergency rooms, power rooms, and the fire pump rooms, and area of refuge. So you were looking at upwards of 225 to 250 hardwired telephones that you had to put into these buildings, as well as an interface in the lobby for the chief to be able to communicate with each one of those phones. And the reason this code was adopted from the International Building Code was that not every fire department in the world, or even our country, had radios for their men. Everyone didn't have a radio. So you couldn't go to a radio system. You had to design some sort of code that addressed everybody's needs. Well, there was an exception put into the code in both the international and the New York City Building Code. And that went, fire department radio systems were approved by the fire department may be installed in lieu of two-way fire department communication systems. So they put the exception in that if you did have radios for your men, you could design a system in a high-rise building that worked with your radios. And for some reason, in the city of New York, this exception was put in by them, exempting R2 occupancies, which are high-rise residential buildings. And that we're trying to have changed. That was an oversight. Then that was for new construction. And then along came New York City Department of Buildings Building Bulletin 2009. This is 2009, 22. And this addressed existing buildings. And what happened was they had numerous permits, probably 1,000 of them, for new alarm systems in high-rise buildings in the city of New York, existing buildings. So what they did was they came out with a building bulletin, and the building bulletin said, system replacements requiring a work permit shall comply with the 2008 New York City Construction Code. And what that was in reference to, one of the things that was in reference to, was the FD communication system shall comply with section 907.2.12.3, which we just discussed, for buildings 75 feet or greater in height. So that meant now that any existing building that was going to change their alarm panel or their alarm system must bring it up to this code. So you can see the tremendous cost savings as opposed to putting in the hardwired phones in an existing building. It was hard enough in a building, a new construction, but now an existing building when they had to do it. So it made it more feasible to use this communication system that was developed. Okay, so what happened was all the engineers and the building owners came to the city of New York and the fire department and said, well, what is this approved radio communication system? And the fire department said, well, we're in the business of firefighting, not radio design. So they put together a committee, and this is where the engineers came into play, the operational people, our communications people, as well as outside consultants. And what they did was they developed a specification, and that was Fire Prevention Technology Management Bulletin 1 of 2011. So that was January of 2011. They developed this bulletin, and in this bulletin, it's some of the bullet points where you had to submit plans for the design of approval prior to starting the work, which you do with every alarm system. Systems must have radio coverage of minus 93 dBm over 97% of each floor with 95% reliability and delivered audio quality of DAQ, of 3.4 or better. And I'll talk a little bit about that in a couple of minutes, but that's all industry standard specs for radio reception and audio quality with regards to radios. Okay, must support analog and digital with 25 or 12.5 kilohertz spacing. Again, this is technical stuff that the FCC is going to require in the future. So the fire department wanted to make sure that the systems that were being installed were going to be able to address the requirements of the FCC in the future. Must be able to transmit and receive the FDNY signaling. Every firefighter in the New York City Fire Department, when they enter a structure, they carry a radio, and that radio has an identification number in it. Whenever they key up their radio and talk on their radio, the ID shows up on a console, and it has to show up on the console of the radio system in the high-rise building. So that had to be incorporated into it, as well as emergency alert. We have an emergency alert button, an orange button that we push, and that button lets the chief know that somebody's in trouble, and it IDs him so that they know who it is that is given the what we call a mayday. Must have battery backup for 12 hours of operation, and this is just from the alarm standard. The alarm has to be backed up with battery, be on a alarm circuit as well as the backup generator. They did the same thing for the communication system. The radio console must be located in proximity to the alarm elevator control panel. So wherever you put the alarm panel, you must also put adjacent to it a radio console for the firefighters' use. It must be operated by the FDNY key switch, which in New York City every firefighter carries a 2642 key to operate the elevators, and they can also get into this cabinet and operate the radio system. And I'll show you a picture of that. Must indicate the presence of AC power and low battery capacity. That's self-explanatory. It has to show that it has AC in it and that the battery is fully charged. Existing building systems must not interfere with FD communication system. If you have a communication system in there for your maintenance people or your security people or some other networking system that you have in there, it can't interfere with the fire department communication system, radio communication system. Okay, how do you go about developing this? How do you make this happen in a building? Well, the first thing you do is a site survey and go over the plans, the plans in a new building, a new structure. Okay, there'll be preliminary testing done in existing buildings where you determine what your RF signal penetration would be in the building, what kind of coverage you'd have to establish what the fire department is requiring. The system design, that's where the engineers would come in. It'd be a line drawing showing the design of the system. Then there would be a radiating coax antenna cable would be installed throughout the building according to the design. A console would be designed and installed. That would be whether it would be in a countertop at the front desk adjacent to the alarm panel or built right into the wall. So all this would be determined by the system development. Radio programming tuning, again, it would have to be programmed for the frequencies for the fire department as well as the coding that had to go in for the firefighters' radios. AC power and cable termination would be done. Then there'd be a commissioning test. This is a very important part of the whole system installation, where you would have to provide documentation to the fire department, and I'll go over that in a second, showing them that you have the coverage that is required by the specification. And then you would put in for a final acceptance test, where the fire department would come in and prove that the system does meet the specifications, and the report that the commissioning report that you gave them was accurate. This is just a sample of a line drawing that would be submitted prior to the installation of a system, and this is just showing the cables where they would be run, the console where that would be located at the fire command center, maybe where the radio would be located in the battery, and what route the cables would take, and the 110 power supply. This is a picture of a RF signal strength meter. Okay, this is what you would use to test throughout the building to determine that you have the coverage that is required by the fire department. Okay, system testing. I talked about the commissioning test that you have to do for the fire department. It plays a big part in it. You first have to establish a test plan for them, and that would consist of your commissioning test, which each floor would be typically broken into a 20 grid square system with testing recorded in the center of each of those grids. So you would lay over the floor plan into 20 squares, and you would test from the center of each of those squares. And I'll show you that in the next slide. A signal level shall be measured with a calibrated RF signal strength meter, which I just showed you that's what you would walk around with. Measurements are to include the signal strength, which would be minus 93 dBm, again, is an industry standard, over 97% of that floor. The delivered audio quality must be at least 3.4, which in the industry means speech understandable with repetition only rarely required and some noise and distortion. This should be a typical floor plan layout that you would give to the fire department, showing the center of each grid and marking it with a number. And this would be the path that you took while recording the signal strength from the system. And you would go 3 to 4 to 5 and go through the entire floor plan, stopping at the center of each grid and recording as you walk. And the data that comes out of that, this would be like one floor's worth of data, and it would show you, I know it's hard to see, but here would show you number 1 square, walking from 1 to 2. This tells you the date, this tells you the time, this tells you the frequency used, which is the fire department frequency, and this would be your signal strength measurements. And you would provide the fire department with this test results, the test results for every floor in that building, including the elevators and the stairwells. Then you'd prepare to do a final acceptance test with the fire department. And what that would require is you file a DOB A433R with the commissioning test report and as-built drawings, and that form, when you fill it out, is requesting an acceptance test. So you request an FDNY acceptance test and an inspection from our fire prevention unit. After that was completed and successful, they would issue you a letter of approval. There'd be certifications that you'd have to do annually, okay? That would require a certification report and a renewal fee by the fire department every 12 months. Then they would require an agency certification where the fire department would come back in every 5 years and do a test to assure that the reports that you've been sending them are accurate and that nothing's changed in that building. Okay, some of the system features. If a system were to fail, members could still contact other members within range of their portable radio. And what we mean by that is if you have a repeater system in a high-rise building, every transmission that's made by a firefighter's radio has to go into that system, get switched to another frequency, and sent back out to the rest of the firefighters in that building. It was something that we didn't see as dependable for the fire service, because if the system were to fail, I couldn't speak to somebody that was 10 feet away or 20 feet away from me who could possibly help me, because the system wouldn't receive my signal and retransmit it. So the system that we developed was a system that that only enhanced the communication between the firefighters in the building and the lobby command. The Fire Command Center can switch through all simplex channels. We have multiple channels on our radio, and when we established a search and rescue group above the fire, we would put them on a separate frequency, just like we would do with the chiefs on the command channel. We would give them another channel. And this system had to be able to use all of those channels, go through all of the channels that are in our radio. It also had to have the ability to communicate with our emergency medical service people and the police frequencies that the police department uses when they come into the building. So we were able to add those frequencies in there in the event that the chief had to get in touch with either of them, he could switch to their channel. The simplicity of the system with the minimal components is what reduces the chance of failure and also lowers the cost. And that's what's impressive about the system, that it's not very costly to install. Minimal training required. Our firefighters are used to the interface, and I'm going to show you a picture of that, because it's the same interface that we have on our fire trucks, our apparatus, that the chiefs use or the lieutenants and officers use, as well as the firefighters. So it's the same interface. Again, the IDs and emergencies can be read at the Fire Command Center. There's a screen right on the console that IDs each firefighter, no matter where he is in the building. A system may be installed temporarily and cost-effectively during construction or demolition phase. This was big when we had the Deutsche Bank building. We lost 2 of our firefighters. They had a lot of communication problems there. Now they're requiring that you have some sort of system in place, and as the building comes down or is erected, you have the ability to communicate at least to the floor below the highest constructed floor or the highest demolition floor. So that's something that's going to be implemented. This is just an overview of the system showing you the radiating antenna cable through the building. The firefighters are communicating directly between one another, and then also their signals going into the radio, and the chief down in the lobby at the Fire Command Center could hear them. And they could also, the chief could also make a transmission, and everybody on the upper floors could hear it. This is a sample of the console that we just installed in the Columbia Presbyterian building. You can see that it's marked Auxiliary Radio Communication System, FDNY use only, and there's a key to get inside the cabinet. When you open the cabinet up, you have an LED light on the top for illumination, handset for the fire chief to use, a speaker, the console, and this is that screen that I was talking about that every ID will come over, whether it be an emergency or regular transmission. You'll see who's giving that transmission. This is your battery status indicator, tells you the battery and you have AC power. And here's that key switch that we talked about, that the fire chief will come in or the firefighter will come in and turn on the system. This is a picture of the system installed. We set up our command post in the lobby. You can see that this is the fire alarm panel, and then this is right adjacent to that alarm panel. It's a requirement by the New York City Fire Department. This would be the remote unit located usually in an electrical closet or a remote area. This contains the radio, battery, power supply, charger, cabinet. And here's a picture of the radio, the power supply, the battery, and this is your AC power. This would be located remotely from the main unit. And then future capabilities of the system. One of the problems that we have in like dormitories right now in the city of New York, where they only have an alarm bell, and as soon as it goes off, all the students leave their apartments and jeopardize their safety because we can't direct them. So what we're trying to develop now is a wireless public address system where, with this system installed in the building, the chief could go to a separate channel and hit independent units that could be plugged in, just like a CO detector plugged into an outlet and become a public address in all of these dorm units. And we could notify them to stay in their apartments, that maybe we have a small fire on the 50th floor, remain in your apartment until further directed by the fire department. And we think it would save a lot of people. That concludes my presentation. Thank you. And if you need to contact me, there's our contact information.